run through a brief demonstration and overview of Converge, the platform itself, and give you an idea of how we enable end-to-end flows to not only be developed, but also managed and deployed as you're moving from one stage to the next into production with your ML and AI flows. So what we're looking at is the Converge IO UI, and I'll spend the majority of the demo actually focused on the UI itself. Do keep in mind that we also support the use of an SDK and a CLI, so there's a lot of different ways to interface with the environment, and that's one of the key benefits. Now, from an end user perspective, Converge is designed specifically to streamline the process of being able to, like I mentioned earlier, not only develop AI and ML driven flows and solutions, but also to manage and deploy them. And Converge does that by actually reducing the high dependence on things like DevOps and IT by making it very easy and transparent to define and identify compute solutions for the end user. And so typically, whether you're developing or running a training workload or even deploying into production, what you're asking for first is a specific compute resource to be allocated for you either by IT or by DevOps. And that typically requires a great deal of effort. So Converge has streamlined that by using compute templates and allowing you to register all of your compute resources in a single place, whether they be in Azure, AWS, Google, on-premise, whether they be DGX clusters or Spark clusters, having all those resources registered to a single control plane, and then being able to create templates that really define and carve out the allocation of CPUs, gigs of RAM, whether or not you're going to need GPUs for the training. And this completely then makes it abstract and transparent to the end user, where that resource lives, how it's being allocated. You can simply just point and click in Converge. And so that's really then paired with containers to really allow you to define exactly what's going to be available software-wise, optimization-wise on that machine, on that resource that's been allocated. And so this greatly streamlines the process of being able to then provision and run workloads as a data scientist, and then be able to hand those workloads off in a reproducible fashion to your ML engineers, your ML ops department. And so Converge does allow you to select images that have pre-built in, pre-baked, and pre-certified software from the Converge directory. And then as you're looking beyond just development and research, and you're looking at optimization, like some of our previous speakers were mentioning, when time matters, when minutes of inferencing matter, you can use optimized containers like NVIDIA's containers for training on GPUs, and to be able to optimize those workloads and save time on your training. And then on the inferencing side, you can also take advantage of our pre-built and fully loaded Intel containers to have optimized Intel containers to reduce your inferencing time and other load as well. And we also support private registries where you can pull your own resources. Now, to kind of drill into an end-to-end flow, we're going to look at kind of an example demo of the NFload use case that we've been looking at here today in the conference. And I'll start off by looking at data sets being a key functionality of Converge. In data sets, you can create new data sets and have a place where you can then upload your data. And this gives you then a fully version controlled data set where you have a commit for every time the data changes. A new commit ID will be created. And so this is useful for a couple of things, namely for AI governance and the ability to track and understand lineage in not only your models, but your endpoints. This gives you a great deal of flexibility and power in understanding exactly, for a particular model that was trained, for a particular endpoint that's being used, in production exactly what model that endpoint was trained on, or what model was trained, and then exactly what data that model was trained on, down to the actual version of the data set that was being used. And so this really allows you to then version all of your data sets and have access to exactly what version you have currently, and to be able to roll back and understand exactly how that data drifted over time. And the other useful feature of that versioning is that it can be used as a triggering mechanism. So as data drifts, you can actually use that to trigger changes in flows to retrain pipelines and do other things. And so that really brings us to the projects, which is really the heart of Converge, and where data scientists, ML engineers, data engineers, where everyone really comes together to develop solutions. And so projects really encapsulate solutions one-to-one. Inside of a project in Converge, what makes it very effective for use in ML and AI use cases is that it really brings together the end-to-end life cycle of your AI, not just a single component. And so as you're in research, you have a place where you can actually create posts and have dialogue and conversation, where you actually link to papers, tutorials, code repos, and have that all saved in the project it relates to. But then you also have a fully version controlled file system, which allows you to then very easily understand exactly what jobs, what developers are creating changes to the file system and how that changes over time. And then easily you can roll back to previous versions of the file system and make changes and compare those diffs all within the UI. And that file system is unique in Converge because it's then shared across every aspect of the end-to-end machine learning and AI lifecycle. And so we provide workspaces then where you can actually, this is where compute and images come back into play. You can easily then scale up your development environment to encompass what it is that you're going to need for the work you're going to be doing. So if you need to quickly add additional GPUs to your workspace, or you want to move into a distributed environment like Spark or PyTorch or Ray, as was mentioned earlier, you can do that by just changing your compute template, and that will completely alter the environment that you then allocate. Furthermore, you can customize the environment by selecting an image that's going to define exactly what type of work you're going to be doing, say PyTorch or TensorFlow, that sort of thing. And once you've made your selections, you can give that a title. You can select an IDE that you'd like to use. We support several different kinds, as well as using a local IDE to interact with Converge. And that then gives you a workspace where you can then begin to develop your scripts, begin to iterate through the process of creating notebooks, creating artifacts that are going to be used in your end-to-end flow. Namely, what's going to train your model, what's going to be used for your inferencing and your endpoint. And these workspaces are fully interactive and give you access to things like those data sets. So here we see I've added my NFlow data set to the workspace, making it then available to me automatically when the workspace launches. And I can browse all my data sets and add them at any time very easily, making it very easy to not only add data, but also to be able to roll back and say, select a particular version of the data that I want to work with, so that I can maybe reproduce some results or look back and understand certain changes in the data itself. And so once you've developed your script, say your training script and your inferencing script, Converge allows you to then seamlessly move forward into the pipelining stage and to define end-to-end pipelines and flows that could then actually automate your work and move you into the production lifecycle. And so here we've got an example where we're actually using the various components of a flow to read in the NFlow data set here and run our train.py, which is the code that encompasses our training. That will then, we can add additional conditional logic if we want to, or even human in the loop validation. And that will then ultimately, once the training has completed, will update our live endpoint. And this endpoint is what we use for inferencing. It's what we can then send an API request to and immediately get back a response. And that's using our inferencing scripts, so that predict.py that we developed in our workspace here. Now, once you develop a flow, you can then decide if you want to use things like continual learning to trigger a on-dataset update, where we can actually watch the NFlow dataset, and anytime a change is made to the NFlow dataset, will automatically trigger this flow to execute. Same is true for a webhook, schedule, if you want to just run this on a scheduled basis, as well as you can run it manually here through the UI or the CLI. And so running a flow will actually then run a series of experiments. And so flows are actually a method for you to define your workload. But at the end of the day, when you trigger a flow to run, what it does is it initializes an experiment for each component in that flow, so that you have full tracking, full traceability, and governance over your pipeline, and you can always go back and understand exactly where a particular experiment originated from. You can see the flow that kicked it off, the version of the flow that it came from. And then you have a great deal of governance as far as the configuration that went into the particular experiment that we see here is running, down to the data set, what version of the data set was used to run this training workload. And as we can see, any visuals that are created, configs and metrics that are created will also be kind of documented here as well. And so as that experiment is initializing here, we can go back and look at what a successful experiment looks like. And so here we see from a flow where we've run this experiment, your visuals will be persisted after the experiment finishes executing, as well as any config and metrics that you log out during the experiment's execution, as well as the full log itself, and any artifacts that are created will have their own commit as well. And so kind of moving from left to right in that flow, after the experiment training phase, the thing that will happen next is the endpoint itself will be updated. And so we provide endpoints that are fully managed and hosted, and also have version control on the endpoints as well. And so each time that flow executes, the output artifacts, the new model that's trained, is actually deployed to that endpoint, and a new model version is recorded. So we can see here that the converge commits are being modified each time, even though the inferencing script is actually static, as well as the compute and the image is being used. Now, there's a lot of subtleties as well to endpoints. You might want to deploy, say, a new version, but you might want to take advantage of something like a canary rollout, where you only redirect a certain percentage of your traffic to the new endpoint so that you can have A/B testing side by side. You may also want to add scalability to your endpoints. So in instances of increased load and increased number of requests at any given time, you might want to be able to scale this up from one pod to many. And you can do that simply by just changing the number here and clicking apply. Now, the flow itself we saw allowed us to account for data drift, but in the model itself and on the inferencing layer, we can also account for model drift by actually tracking the tag.
Vasilis?
Yes.
Hi, Vasilis. We need to finish because we are short on time. Are you at the end?
Yeah,
so please try to finish.
Yeah,
thank you.
So we're pretty much finished here. And so, yeah, the last thing I'll mention is with continual learning, you can actually track the any particular metric. So you can look at the health or bias of a particular model, and you can, while it's actually in production, you can set thresholds, which can trigger emails to be sent or flows to be executed. And then with a live endpoint, you can then, from a workspace, or then from your application and your actual infrastructure, you can then leverage the endpoint itself to begin sending commands. In this case, SQL requests, which will instantly, as we see in very little time, give us back a response for that particular NFID. And that really kind of concludes the demo of Converge. There's a lot more that you can check out if you want to look at converge.io/developers or anything like that. But yeah, thank you for having us here today, and appreciate your time and attention.
Thank you very much, Vasilis. Very interesting. Sorry for the short time. Our next